Hello? Hey guys, can you hear me?
We can hear you.
Awesome.
Yes.
All right, we got a couple minutes. Just wait for some other folks to join us. We've got quite a large class, so let's see who shows up. If the sound is too loud, just turn it down on your end. All right, hopefully you all can hear me. Hello, my name is Shondine Deputy. I will be your instructor for this semester. So it's 5:01. Looks like I've got about 4 people with me. So I'm gonna go ahead and just get started. We've got a lot to cover today. So I'm gonna take roll. It looks like we have Brendan. And just unmute yourself, give a quick hello so I know your microphone is working.
Hello.
Hi. Cameron.
Hello.
Hi. Carlita.
Hi.
Hi. Robin. And Grant. See you guys there. We'll go over some Zoom stuff in a moment. And if, oh, I see Robin, you unmuted. Can you say a quick hello so I know your mic is working?
Hi.
Hi. And then Grant, how about you? So if you look down along the bottom of your screen, there are some buttons down there.
Some lives here.
Yeah, I think you've unmuted, Grant.
Right.
I can hear your background. Just want to say a quick hello.
I think I need a flower for real. Flower power.
All
I
right.
need that green mark.
So just some quick housekeeping rules before we get started. If you're not talking or you don't have anything to say, make sure you keep yourselves muted so we don't pick up the background noise. I'm trying to keep my door closed so you don't hear my kids in the background. Because it's an evening class on Zoom, I do teach from home. So if you feel like my background noise is being too loud, please let me know and I will let folks know in my living room to keep it down. And so other things, it's okay to keep your video off. I know sometimes the video eats up your internet connection, so that's fine. But if you want to show your lovely faces and take yourselves off a blank screen, that's fine too. If you're looking down along the bottom of your Zoom screen, you'll notice there are some other things in there. So we've got some reactions. We got the reaction button. So if you want to raise your hand and you have a question, feel free to click the raise your hand button. Okay. I don't really use breakout rooms in this class. Everything I do, you can either unmute yourself or you're going to use the chat button.
Oh, I died.
Okay. So the chat, just so that I know everyone knows where chat is, if you guys would say a quick hello in chat, just type in hello so that I know you are there. I use the chat feature quite often. We will do a lot of problems in this class, so I will work a lot of the homework from the textbook. I will do all of the even problems, and so that's how this class is going to work. Great. I see Cameron, Carlita, Brendan, Robin, okay, Vanessa. Right, so the chat feature, again, use the chat. You're going to use it to type in your answers so that I know you are understanding the problems. A lot of times it takes a lot of time away from what we're doing in class. So I don't really have students write on the screen. I may every now and then, but for the most part, you're going to use your chat to answer any of the questions that I post up onto the whiteboard. Okay. So let's go ahead and jump into Moodle. Okay. So you all should have access to your Moodle account. This is where you'll find all of the information for this course. So you are in Math 109, Introductory Algebra, okay? My information is right here. I do have my office phone number, although I travel quite a bit to all of the different campuses. I do teach 4 other classes, and so I'm rarely in the office. So I do prefer that you use Moodle Message, okay? You'll notice up here in the top left hand or right hand corner, if you're new to MPC this semester, there is a little bubble here. When you click on that, it will open up the chat feature. You'll just type my name into the search engine there. Okay, click on the magnifying glass, and then you'll find me, Shondine Deputy. So you'll come down here to the message at the bottom. You can type your message in and then click on the airplane and it will send it to me. This is the quickest way for you to get a response from me. I am in Moodle all of the time, and it not only sends it to Moodle, but it also copies the message to me in my email, okay? And I will do my best to respond to you within 24 hours. If it is within the working day and I'm not teaching a lecture, I can get back to you as long as it's before 4 p.m. Okay. Any announcements that I have, I will post it in here. Okay, so I did include a welcome earlier this week. I did ask you to send me the location, so your campus. We're going to go ahead and scrap that. I didn't have too many responses to this, so I went ahead and put your Rocketbook beacons in the US postal mail today. Okay, so at some point by the end of the week, you should be receiving your Rocketbook beacons in the mail. So make sure you check your mail. And I went off of the mailing addresses that you used when you registered with MPC. Okay. If for some reason that's not the address you wanted to have it sent to, please send me a message and I can contact Holbrook and have them stop that before it goes out. Okay. But otherwise, check your US post office or wherever you get your mail. And so Rocketbook beacons, they look like this. They're 4 orange triangles. They got mailed out to you. I know some of you didn't quite understand what I meant by that. And so I use Rocketbook beacons for this course, and I have you submit your homework into Google Classroom. Okay, so what I need everyone to do is to download the Rocketbook app. So we've got some videos. So I've got a video that introduces you to what a Rocketbook beacon is. Okay, so there are 4 triangles. I also have in this next window, you can see how to submit. Okay, so how do you use your Rocketbook beacon to submit your homework to Google Classroom? And if you're not familiar with Google Classroom, I also have a video in here, okay, that tells you how to use Google Classroom. Okay, so those again, they went out today, so check your mail by the end of the week. Okay. Again, Moodle message, best way to contact me. We will meet on Zoom every Monday from 5 to 8. And it was a little confusing. Last semester I taught from 6 to 9 and I thought we were on the same time, but it got moved up an hour. So we're 5 to 8 now. Some additional resources here. So tutor.com, I will refer you to tutor.com. It is a 24-hour service. And so if you're somebody who likes to work late into the night as opposed to early in the morning, tutor.com is there for you. Technology issues, contact 7447. The support center can help you if you're experiencing difficulty getting into Moodle. If it's difficulty getting into Google Classroom, I suggest that you make sure that you're using your NPC email, okay? I do have several people that tend to try to get into Google Classroom from their personal email, and that's not gonna work. NPC's email is a Gmail account, but the difference is after your username, you get an @mail.mpc.edu as opposed to @gmail.com. Okay, so that is like if you're having trouble again getting into Google Classroom, it's probably because you didn't switch over to your NPC email. Okay. So again, contact 7447. If it's a Moodle thing, chances are I can't fix it. It has to go through the support center. Okay, I do have a link here to the syllabus. It is in a PDF format. Okay, I'm going to pull it up here. We'll go through this in a little bit. But I've got all of the information in here. Each week is broken down by what assignment that we are going to do. This is a 16-week course. You will have a midterm, you will have a final. The final is a take-home exam, and the midterm is completed in Moodle. So the midterm is timed, but I will have a study guide that goes out that will help you get through your midterm. Okay, we'll come back to this. Okay, again, here are this is a book. So when you click on it, it will open up, your side will look a little bit different. You'll have some arrows down here that you will click on, and it'll help you navigate through the book. So there are videos in there and there are how-to guides. Okay, Zoom link, everyone got into Zoom. So again, it's right here. If your audio is not working at your location, you can try and dial one of these phone numbers. So you can get on Zoom and then dial one of the phone numbers for the audio. My office hours are all on Zoom, although my office is located in Show Low. Again, I travel around a lot, and then I work from home on Tuesdays and Thursdays. And so because I teach all day Monday and Wednesday, my office hours will be Tuesday and Thursday. They're right here. If these hours are not ideal for you, you can always send me a message and we can schedule an appointment outside of these times. I don't have a lot of people who come to me for help, but you know, I am here. I want to work with you, and I want to help you understand the content. So if these don't work, just send me a message and I can schedule you in at another time. I save Tuesdays and Thursdays for meeting with students, and so I can squeeze you into these times or into these 2 days. And evening is an option, but again, you have to reach out to me, need to send me a message, and I can schedule a time to meet with you in the evening if if you happen to be working during these times. Okay. Any questions so far about my office hours or anything that I've covered so far? No? All right. So I've got some videos here. Okay. These are videos that can help you if you feel like you struggle with fractions, or if you don't understand what prime factorization is. These 4 videos you'll want to watch because when we jump right into chapter 1, it's with the understanding that you already have a solid foundation in fractions and factorization. Okay. Watch the videos. If you still feel like you're struggling a little bit, again, tutor.com, or you can reach out to me. Okay, so these are just some beginning resources to help you as we move into chapter 1. So how I set up each chapter is that we have a link here, okay, for some learning objectives. Share my screen instead. Okay, so these are all of the things that you are going to learn within chapter 1. And then I go into further detail down below, talking about what are some further things that you will learn in the chapter. Okay, there are some videos here, right? So not everybody may understand the way that I teach. And so there are some other resources to help you. Khan Academy is a great one, and then YouTube has videos as well. Okay, for those of you who reached out about the textbook and not having the textbook right now, I did upload the first 4 sections of the textbook. Again, because of copyright issues, I can't upload the entire textbook. But if after next week you still don't have your textbook, I'm willing to upload a few more sections in here. All of your homework is going to come from every section. Okay, so you'll notice down here that I do have a link to Google Classroom. You do have to go to your NPC email and accept my invitation. Okay. So what you'll end up doing is you will use your Rocketbook beacon to link each section, to link the PDF into each section. Okay, so you'll notice here section 1.1, upload your homework using your Rocketbook beacons. You are only required to do every other odd problem. Okay, so that would be 1, skip 3, 5, skip 7, 9. Okay, but if you do every odd problem, you will get extra credit. Okay, so I'll tack on a few extra points if you do extra credit. And trust me, doing extra credit, they do add up. Okay, those points will add up quickly. So I've linked, right, I've got a link in Moodle for every section where you will upload your problems. Okay, and the hardest part is linking Rocketbook to Google Classroom, but once you get those linked, your Rocketbook beacons act like a scanner. Okay, so it just scans the pages into your phone, and then you submit your homework directly to Google Classroom. So this takes out the hassle of you guys going into campus, trying to find a printer with a scanner, and trying to load everything. Okay, so this takes out that. You can just do it right to your phone. If you're struggling linking Rocketbook Beacon to Google Classroom, again, reach out to me and I can arrange a time to meet with you. After every chapter, okay, so you'll do all of the sections listed, every other odd. You do need to complete the chapter reviews. Okay, you will have a quiz. So you'll notice here, quiz one will open next week. I will get this changed. Okay, most of the quizzes are 2 attempts. To change this one. You get 2 attempts and I will take the highest score. Okay, so 2 attempts on the quiz. The quiz, it will depend, some of them may be 10 questions, some of them may be shorter, just depends on what is covered in that chapter. You'll notice when you go in there, it'll give you a time limit. Okay, so again, you get 2 attempts. I usually give about 2 weeks for the quiz to be completed. And then that gives you additional time to complete all of your homework. Okay, I recommend doing all of the homework before taking the quiz, because again, math is about the practice, right? You have to practice, practice, practice. All right, so let's go ahead and take a look at the syllabus. Okay, so you've got the description. It is 3 credits. Okay, and so the goal is for you to get a good understanding and foundation in algebra so that you move on to Math 112, which is intermediate algebra. I do use the introductory intermediate algebra textbook. So this is the textbook that we will use in the class. Okay, it can be purchased from the NPC bookstore. You can go onto Facebook and look at the NPC Book Exchange. I've seen these in there for quite reasonable price. Or you can go through Amazon or any other website, Chegg, you can rent it. Okay, but just make sure you get this algebra book before we move into chapter 2. You are allowed to use a calculator. Okay, I don't use the TI-83, like we don't do much of that in here. A lot of what you graph will be on graph paper. I do recommend your spiral bound notebook, so you keep all of your notes and your homework in there. And then the graph paper will help you toward the end of the semester. We'll do a lot more graphing at the end of the semester. And then just making sure you have reliable internet connection. I will not accept any late homework unless you reach out to me. Okay. And, I'm pretty flexible, but you just need to contact me and let me know what is going on with you so that I can make the necessary arrangements to extend anything that needs to get extended. Because, we are in a time where folks are getting sick, and my entire family was sick right before the semester started. And so I know, we've got things going on, maybe you're working, you could get overwhelmed and maybe feel overloaded. So just reach out to me and please let me know if you need an extension. Okay, we don't want to have a quiz and then the quiz passes and you didn't let me know. Okay, so all homework should be submitted prior to the next chapter quiz. So before we start chapter 2 quiz, you need to have all of chapter 1 homework turned in. And I assign odds because I want you to be able to check your work. Okay, but I will be checking your homework to make sure that you are working the problems. So making sure you always show your work. I want to make sure that you are understanding the process, right? The steps necessary to solve the problems. Okay, so practice tips, do your homework daily. Even as an instructor, right? As a math instructor, I have to practice. So I've got my own notebook here. I'm going to make sure that I do all these problems that I'm teaching you just to make sure that it stays at the front of my mind. Practice, practice, practice. That is what math is. You can do your homework with classmates. So if you guys, want to get on Zoom yourselves or whatever, you guys can practice together in groups. It's highly recommended. Or tutoring. When you cannot solve a problem, I recommend you take a highlighter and highlight that problem so that the next time you come to class, you can ask me. And if you can't find your mistake, start over. Get another sheet of paper and try it again. And as I said, show your work so that I know you know the process. When taking a test, do all of the easy problems first and then circle around back to do the problems you didn't understand. You never know, by doing a problem later in the quiz, you may find the answer in completing that problem. Okay, so there are 6 quizzes. We have 6 chapters to cover. Okay, I will open them on Thursday and they must be submitted, okay, by the following Friday. Okay, so you get about a little over 1 week to complete the quizzes. Okay, so 10 questions, 20 minutes, you get 2 attempts, and I will take the highest grade out of the 2. There will be 2 exams. You will have a midterm that covers chapters 1 through 3, and then you will have a final exam that covers chapters 1 through 6 with an emphasis. So there will be a lot more problems covering chapters 4 through 6. And this one, I needed to fix this. I just realized it now. Your final is a take-home exam. Okay, so it's got 50 questions. You take it home, you get a week to finish it, and then you send it back to me in Google Classroom. Again, extra credit can help boost your grades. So the more problems that you do, so if you're doing every odd problem, it can help boost your grade. Okay, and then this is how I grade. Okay, so it is a weighted system. 25% will be on your homework, 15 quizzes, midterm and final are both 30% apiece. So do not miss those 2. Okay, do not miss them. It will drag your grade down drastically. The topics that we'll cover. So we will jump into chapter 1 right away. So we'll cover real numbers. And then I've got, again, the breakdown here, our course schedule by week. Attendance, right? We want to make sure that we are attending. If for some reason you miss a class, I will post the lecture recording, okay? And you will find the lecture recording in Moodle after every, or within the chapter that we are working on. Okay, MPC email, you have to use your MPC email for Google Classroom. You have to be able to access Moodle for your quizzes and your exams. Again, Rocketbook Beacon, we've already covered that. Additional resources, you'll find them listed here. So tutoring, Office of Accessibility and Inclusion, the information is here. Okay. Academic honesty, so making sure that you are the one who is completing the homework and not somebody else. So you're responsible to complete your own homework. I don't use Starfish, but I put it in here. Safe colleges, right? How to be safe on campus. And then communication. Okay, so this is the progress record that I will use for this course. Again, the weight that each 1, 2, 3, and 4, you'll see over here how much I will designate the weight to your grade. Okay. And I will also make sure that whatever homework you are submitting in Google Classroom, you won't really see it other than when you go in to view your grade, but I will have a section where I put your grade. So however many points you got on the homework assignment, I will have it linked to Google Classroom. Okay, so I will make sure that is continuously updated. All right, does anyone have any questions thus far? No. All right. Let's just jump right in. So again, if you do not have the textbook, remember we do have in here, I've got some copies of it. So you can go ahead and open that and just follow along. All right, thanks, Vanessa. Yeah, so from here on out, we're making sure we either use chat or you can unmute yourself and chime in. Okay, so we're just gonna jump right in. So you should be seeing the PowerPoint up on the screen. It is titled Chapter 1, Real Numbers. Just let me know if you can see Chapter 1, Real Numbers. And if you guys, if there's ever a time I like start rattling on and you don't see my PowerPoint, just let me know. I have a tendency to forget to share my PowerPoint. Bad habit. So anybody, let me know if you can see Chapter 1, Real Numbers. Sorry guys, let me have my kid log off the internet because I don't want to get kicked off again. Hold on. All right. No, I'm teaching. All right, can you guys see my PowerPoint? Sorry about that.
Yes.
All right,
Yeah.
awesome. Okay, so right now we're jumping right into Chapter 1, Section 1.1. Okay, so we're talking about real numbers, and Section 1.1 is the real number line and absolute value. So we've got different types of numbers. Okay, we've got different types of numbers. So we've got natural numbers. Okay, we've got whole numbers, integers, and then irrational numbers. Okay, so if we take a look at the example that we have up here, okay, so we can see that natural numbers looking there are positive numbers. Okay, so let's take a look really quick at a number line. Okay, so the number line, right, is our line. Okay, and we have 0 here. And so we would label it positive on one side and negative on the other. Okay, and so any number going above, okay, we have whole numbers. Okay, and when we think about whole numbers, we want to think about whole numbers, right? So let's pretend I had a circle here. And so this entire circle represents 1, right? We're not talking about half of a circle, right? That's not what we're talking about when we're talking about whole numbers. We're talking about an entire, whatever it is we're counting. So in this case, it's the entire circle. So we would represent that as 1. Okay, and when we keep counting whole numbers, not what's in between, not parts, but whole. Okay, so that's why we call them positive, right? Positive numbers. And for the sake of this class, we're calling those integers, positive integers. Okay. So we have positive integers, natural numbers, we have whole numbers, it includes 0. And then we have integers, okay? Integers are negative, right? They include all of the negative numbers, okay? And we use integers the most, okay? So when we add and subtract, when we're moving across, back and forth across our number line, we are talking about integers. Okay, and then irrational numbers. So let me get this, minimize this one, hold on. Okay, so real numbers. We can use this diagram to help us understand the difference between natural numbers, whole numbers, integers, and rational numbers. Okay, so rational and irrational are classified as real. Okay, we don't necessarily work too much in irrational numbers in 109. We may see pi. Okay, but for this class, we work a lot with the rational, the integers, whole, and natural. And so it's important for you to understand what the difference is between the different numbers. Okay, so I'll let you guys take a moment, make sure you write this stuff down because this will be on the quiz, all right? You need to understand the difference between natural, okay, positive integers, whole numbers. Whole numbers include positive integers plus 0, right? 0 is included. Okay. Integers, so negative and positive. Okay, and then irrational numbers, all right, are infinite, non-repeating decimal numbers. So if we put the square root of 2 into the calculator, I'll go ahead and do that on my side. That number, I want to see what it's going to equal. It's going to be this decimal, 1.41423562. Okay, so non-repeating decimal numbers, right? It'll keep going to a point, and then infinite means it stops, right? It stops. It's not going to keep going. Okay, so irrational numbers, infinite, it's going to stop somewhere. Non-repeating decimal number. Okay, and what we mean by non-repeating is sometimes we can have decimal numbers that are just going to keep going on and on forever. So we call those finite. They keep going, they never stop. And we use this bar above it to say that it keeps repeating, keeps going and going and going. Infinite means it stops somewhere. So the decimal numbers at some point will go, but then it will stop. Okay, so that is what we call irrational. Irrational. Then we have variables. Okay, variables are usually a letter, right? A letter from the alphabet, and they represent an unknown number. And the most common type of variable that you will see is X. Okay, X is going to represent a number, and it can represent any real number. Okay, so any real number. So if we see something like X equals 2, and then the variable X is representing 2. Okay, we might see A equals 3. Okay, so again, the variable represents an unknown number, or it could represent more than one number. So variables. Okay, so in section 1.1, you are going to be asked to draw the number line. And you're going to draw the number line to represent numbers. So up here on this number line, we see integers, both negative and positive. Okay, and then we also see 0. Okay, and number lines, right? We can see number lines in everyday life. Okay, so a good example of a number line is if we do a number line going up and down. Okay, and we might see 0 here, right? And I want to know the temperature, right? So thermometers are a good, right? They're a good way for us to see. And then we could see temperatures going negative. Okay, so real life example, we could use a thermometer. Another way to think of a real life number line is to think of your bank accounts. Right, so we could say, you know, when I put money into the bank, right, it goes in a positive direction. And when I take money out and I spend it, I'm going a negative direction. Okay, and then the other example would be, we've got this guy in here and he's digging a ditch. Okay, and so he's here on level ground. So that is 0. Right? We're starting off at 0, the ground is level. And every time he digs down into the trenches, he's going in a negative direction. And all of the dirt that gets piled is going in the positive direction. Okay, so when you think about a number line, you want to think about going in negative and positive directions. So let's take a look at some problems. Let's jump right into some problems. Are there any questions about the number line or a variable? All right, so on page 12 of your textbook, okay, right off the bat on page 12, it asks you in questions 1 through 6 to list, okay, so it gives a list. We're going to go ahead and do number 2. So whole numbers, right? Thinking about what the definition is, whole numbers. And take a look at the list they've provided. So when we have a list, in math, we call that a set. Okay, so we've got a list here. So we're going to call this set A. So set A, I'll put it up here. All right, this is set A. Okay, so in this set A, what are the whole numbers? Okay, so in the chat, thinking about what our definition is of whole numbers, what are the whole numbers in set A? So in the chat, what are the whole numbers? So remember, whole numbers are your positive integers, and it includes 0. Okay, so 0 plus your positive integers. And whole, okay, I want you to remember that word whole number, not a part, right? So a part could be in a fraction form. It could be a decimal form, right? These are parts of a whole, okay? So whole numbers, that's your key there, whole numbers. Good. Yeah, good. So we can see, right, 0, that's a part, that's a part, that's a part. We've got a whole, that's a part, and that's a whole. Okay. Let's look at number 4 now. Okay, and number 4, irrational numbers, irrational. So think about the definition of an irrational number. So an irrational number. So in set A, what are the irrational numbers? And I'll go ahead and pull up the PowerPoint really quick so you can take a look at that definition. So irrational numbers in infinite non-repeating decimal numbers. And so we're going to circle everything under the square root symbol. Okay, and then let's go to 6, real numbers. So in set A, what are the real numbers? What are the real numbers in that set? Set A. And this chart here is a good example of real numbers. Okay, so if we imagine a plane of numbers, the real numbers are everything. So rationals, integers, wholes, naturals, and irrationals. Real numbers are everything. So what we would put here then is set A. Okay, so real numbers is everything in set A. So all of the numbers in here. Okay, something else to remember about the number line is that when you go to the left of the number line, okay, you are going in what I would say is a negative direction, and your numbers are getting smaller. Okay, so the numbers are getting smaller. And then when you move to the right of the number line, you are moving in a positive direction. and the numbers get larger. The opposite of a real number is called its additive inverse. Okay, so the opposite of a number, a real number. So for example, we have a plus a negative a equals 0. Okay, and if we see that, if we plug a number in here, okay, we understand that 3, and when we move in the opposite direction, so for example, we start here at 3, okay, and we move in an opposite direction or in the inverse, -3. So if we moved back 3, we would arrive at 0. Okay, the same thing with 7. If we were over here at 7 somewhere and we moved in the opposite direction, the same amount. So if we moved back 7, we would arrive back at 0. Okay, and that would apply to whatever we put in here. Okay, so the additive inverse means we come back to 0. Okay, so in the chat, give me an example of an additive inverse that I haven't listed here. Okay, so in the chat, give me an example of where we start at 1 integer and we move the same amount in the opposite direction and we arrive at 0. Yeah, so how you would write that, Cameron, then would be 1 plus -1. Or you could say 1 minus 1. We could drop the parentheses. Okay, and we arrive back at 0. Yeah, good. So Robin, just make sure that the operation you put, so that equal sign is an equality symbol. So we want to make sure we're using, right, an addition sign or a subtraction sign. Good, so the additive inverse. Okay, so here's some more examples of rational numbers. Okay, so they could include fractions. So we've got different examples. We've got our proper fraction. Okay, so we've got a proper fraction of 1/2. Okay, we've got another proper fraction of 4/9. Okay, we have the mixed number there, 7 3/8. Okay, it could be an improper fraction. Okay, we've got terminating decimals, so they end. And then it could also include repeating decimals. So again, the bar above the top. Okay, irrational, we've got these different crazy patterns. So we can notice this one has a pattern. This, again, this group, you won't see it in 109. Okay, but it's just good to kind of, it's out there, right? We've got irrational numbers, but we won't cover it here in 109. It's this half over here. Okay, this is the stuff that we will be working with. So rational numbers. One thing to remember in fractions. Okay, so we have the fraction A over B. Okay, and in fractions, B can never equal 0. Cannot equal 0. So when you have an equal sign and you put a slash through it, it means cannot. It can't happen. So you can never have a 0 in your denominator. And if you find that 0 ends up in the denominator, we call that undefined. Or you may put no solution. Okay, so there will be times in your answer where you will use one of these two. You will tell me it's undefined, there was no solution. because there is a 0 in the denominator. If that's a rule, we cannot do that. Any questions so far about some of these little rules? So we covered that one. All right, so now we have inequality symbols. Okay, and so there is a chart right here. This is the most common one, these three that we know. So is equal to, when the symbol is closed toward the number, it means is less than. And when it is open toward the number, it means is greater than. Okay, we have some new ones over here if you haven't seen these. So this is the one I was talking about. A line through your equal sign means it is not equal to. With the line under it, it means is less than or equal to. Okay, so the line says it is equal to, less than or equal to. And when we have the line with it open toward, it is greater than or equal to. Okay, so here is an example over here. And so we can see there, we have 0, the symbol, and the 3. So we would read that 0 is less than 3. Okay, we've got that -2 with it's closed and then 1. So you read that -2 is less than 1. Okay, and the last example is -5 is less than -3. Put some examples on the whiteboard in a moment. And so in this course, you are going to graph inequality symbols. So again, these are the 6 inequality symbols that we will use. Okay, and you will learn how to graph them. Okay, so when you see is greater than, okay, there's no line underneath it. You want to remember that when you put a circle on the number line, the circle is open. Okay, and when it is open, it indicates that it is not equal to. Okay, it means so it's not colored in, so it's not equal to. Okay, so it is only greater than. It is only greater than 5. The same thing applies to less than. It's not colored in because it's not indicating that it is equal to. It is only less than. And then you color the dots in on the number line when you see that it is greater than or equal to and less than or equal to. Okay, so in this case, you would read that it is less than or is greater than or equal to 3. Okay, and so you want to remember X, right? X equals all the real numbers. X equals all real numbers. So if I look at this one here, I'm saying that 3 is all the numbers that are greater than and equal to 3. Okay, all the numbers greater than or equal to 3. And when I read this one here, I'm reading all numbers. So X is all real numbers less than or equal to 5. Okay, so all the numbers that are less than or equal to 5. Okay, so that is how you will read that. This one is important. X is all real numbers. And then you read the inequality symbol. So before we go to absolute value, I know you guys can't, you can't necessarily draw on the board, but I want to do some practice on these. And then I'll just have you guys check. Okay, so we're on problem number 18. So number 18. So it says all whole numbers less than 7. So in your notebooks, okay, you're going to graph the integers on this real number line. So you are going to create a number line in your notebooks. Okay, and think about this meaning. So all, okay, we want to understand what is whole numbers. So all whole numbers. So first, define whole numbers. And then read the next part of this, less than 7. So first, define whole numbers and then less than 7. Give you guys a moment to do that. In the chat, tell me which numbers did you plot? Close, Cameron. Look at the part that is underline, has one underline, less than 7. So all whole numbers less than 7. So we have that inequality, those inequality symbols, equal to, greater than, less than, not equal to, right? So what does that mean? Yeah, those look good. Autumn, Brendan. Yeah, so whole numbers, right? Whole numbers are 0 and positive integers, whole integers. Okay, so it's gonna be 7. So 1, 2, 3, 4, 5, 6, 7. Okay, it has to be less than, right? So it can't include this. So I won't plot that one. It's not gonna include it. It has to be less. And whole numbers, right? Not parts of, but just whole. Right, and so if you said 0 through 6, or I saw some of you just listing, right? As long as we don't include 7 in that, all whole numbers less than 7. Good. All right, so number 20. All negative integers greater than or equal to -3. So all negative integers greater than or equal to -3. So again, in your notebooks, right, you've got your own number line here. In the chat, what are we plotting? So think about that first part, all negative Right, so negative integers, think about that. And then we've got greater than or equal to, greater than or equal to. Okay, so negative, right? Negative integers are less than 0. Okay, so anything to the left. And so I will, right, we'll go down to -3 because that's where it says. So greater than, right? Greater than is going the opposite direction in a positive. So we're going to plot everything to the right, but it has to be negative, right? So negative, less than 0. Okay, and it's greater than or equal, right? So equal to means we are going to include -3. Okay, and then the other whole negative integers. So yeah, -1, -2, and -3. Good. I'll do one more. 22. All integers less than 8. Okay, so get your number line out there. All integers less than 8. Okay, so this symbol is infinity. It means it just keeps going and going and going. Okay, when we're talking about integers or whole numbers, sometimes you'll see 3 dots at the top, and the 3 dots indicate that these are whole. These are, you're continuously plotting whole, not whole numbers, excuse me, integers. Okay, we're not doing parts, right? We're not doing parts, but we're doing whole. Okay, so we could do dots over here too. Okay, infinity means everything. It means that if I just kept going on this line, it would mean that I'm including stuff in between, right? In between these are whole numbers on this side. Close, Carlita. So think about which direction. So if you put the dots on this side, you're telling me you're getting greater or moving in a positive direction. But if you put the dots on this side, right, you're telling me that you're going negative. Yeah. Or yeah, you could write it out 7 to the negatives. Yeah, that's fine. Yeah, so all integers, that's important, all integers going that direction, less than 8. So we have 8 somewhere over here. So we're not including 8, but we are including everything less than 8. Yeah, so we use those dots. Okay. So that is plotting. Okay, and something else that we have in section 1.1 is called absolute value. An absolute value is represented by those symbols on both sides of this variable x. Okay, so absolute value are 2 lines on both sides of either a variable or a number. So inside the absolute value, you could have both positive and negative numbers expressed within an absolute value. And what absolute value means is that opposite numbers are always the same distance from zero. So if we take a look at this number line here, okay, we are looking for the absolute value. Okay, so it says the absolute value of all numbers is equal to 3. Well, again, absolute value is the distance from 0. So if we look down there on the number line, 3 is plotted. So you're counting the distance from 3 back to 0. Okay, and that distance that you counted is 1, 2, 3. Okay, so the distance away from 0. Let's take a look at this one. Okay, so the absolute value of 6, right? We're counting the distance 6 is away from 0. And if we counted that, then that distance from 0 is 6. Okay, what about this negative 5? The absolute value of negative 5. Well, if we take a look at 5 here and we count that distance back to 0, it's 5. Okay, so the absolute value of any number inside the absolute value symbol, whether it is positive or negative, the answer is going to be positive. Okay, and if we have something that looks like this, okay, then we would say that there is no solution, right? That can't happen. Right, because we're not saying that the distance, right, the distance from 5 back to 0, right, that's not a negative, right, that's not negative. Okay, the same thing here, that's not negative. It's just the distance we've counted is 6. Okay, so you have to remember that the absolute value is always positive or 0. Right? Because if we are plotting 0, and I'm saying the absolute value of 0, well, we're not moving any direction from 0. It's just right at 0. Okay, so that's a rule. Absolute value is always positive. And if for some reason you ended up with a negative out here, you say that's no solution because that can't happen. So we'll look at one more example here. Okay, so we've got, again, -4, right? Back to 0 is 4 units, the distance. And then we have a +5, but the distance back to 0 is still 5 units. Okay, so it's always positive or 0. Okay, so in the chat, what is that? Negative, the absolute value of -12. Good. Okay, number 32 from your textbook. Okay, what is the absolute value of -5.6? Yeah, good. It's 5.6, right? It's always positive. Oops, didn't mean to do that. Let's look at 34. Okay, now we have a negative on the outside of the absolute value. Okay. So what happens then is we drop, right? We drop the absolute value. So it comes out of the absolute value symbol, okay, as positive, but we have that negative out there. So it stays on. Okay, so then the answer stays negative 3.4. But you have to remember it's because we still have this negative symbol out here. So even though this came out positive, okay, we still have a negative out there. So the negative symbol still stays on there. Okay, what about that one? Good. What about that one? Yeah, good. So it stays positive when it comes out, but we've got the negative. And that last one. Good. All right, 37 through 45, you're just doing the appropriate symbol. So is it greater than, less than, or equal to? I'm gonna go ahead and skip over that one. Let's go over to 52. 52 in your textbook. Okay, so it wants you to determine whether or not the statement is true or false. And if it is false, we want to rewrite it so that the statement is true. Okay, so let's take a look at this statement. Is it true or false? So 11 is equal to negative times negative 11. Okay, so these are parentheses, not absolute value. Okay, so in multiplication, right, when we're multiplying integers, we have a couple of rules we want to remember. So when we multiply two positives, it equals a positive. When we multiply a negative times a positive, we get a negative. And then when we multiply a negative times a negative, it equals a positive. Okay, so we're going to take a look first at this portion. Negative times a negative, right? So a negative times a negative makes that a positive, right? So you might rewrite it positive 11, or we could just drop the positive and just put 11. And we know, right, that those two are equal to each other. So that statement is true. Okay, so we want to remember some of our rules for multiplying integers. So I will do another one. So problem 54. Right, so we have negative 6 is greater than negative 8. Yeah, looks good, right? Because on our number line, negative 8 is here, negative 6 is here. This direction is bigger. So definitely that is true. Let's look at number 56. 4.7 is greater than or equal to 3.5. .7 is greater than or equal to, right? So let's read that out loud. Greater than or equal to. Okay, so I'm getting a number of falses, right? Because if we plot that on the number line, so we have 3 here, 4 and 5, right? 4.7 is somewhere here, 3.5 is here. Those two are not equal to each other. If they were equal, they would have to, each dot would have to lie on top of the other. So it's definitely right. It's not equal to. So we'll say this is false. Okay, because it's false, you need to make this a true statement. So in the chat, how would you make this a true statement? How would you change that? Take away the bottom, the equal to. That sounds good. So what would that look like if you typed that into the chat? That looks good, Cameron. I like that. Is that Brendan? Yeah, you can write it out. You can use the symbol greater than. Okay, yeah, definitely. Right, so we would take that away. So you could say 4.7 with the symbol greater than. Or I had somebody write it out, 4.7 is greater than 3.5, not 35. Okay. We'll do one more of those and then we'll take a break. Well, we'll do two more. 62. The absolute value of -6 is greater than or equal to 6. The absolute value of a -6 is greater than or equal to 6. So first we'll solve this. So anything in an absolute value becomes positive. Yeah, so first, right, if we have something like this, let's go ahead and solve and then rewrite it. So now let's reread that. 6 is greater than or equal to 6. So we'll do our number line. Six is over here. So 6 is greater than or equal to 6. Is 6 bigger than 6? Can we say this? Yeah, 6 is not greater than 6. 6 is equal to 6. 6 is equal to 6, right? Because it's not greater than. It would have to be on the number line, right? Going this way, we'd have to have other dots over here to say greater than. So it would be false, right? Because it's not greater than the equal to, right? So we would just say, to make that a true statement, we would say equal to. Yeah. All right, and then we'll do 70. So the absolute value of -1.6 is greater than the absolute value of -2.1. True or false? We've got a couple of back and forth, some true, some false. So in the chat then, tell me, what is the absolute value of negative 1.6? What is this? Solve this one first. Yeah, 1.6. Okay, now solve the absolute value of negative 2.1. Yeah, 2.1. Now, what symbol would you put in the middle? How would you rewrite that statement? So remember, the symbol opens up to the bigger number. So it opens to the bigger or the greater number. Yeah, so 2.1, right? If we plotted these again on the number line, 2.1 is over here and 1.6 is about probably there, maybe a little bit the other direction. Okay, so this statement up here is false. Okay, sometimes it's helpful to plot to see where do these numbers lie. Yeah, I've still got some time till 6:30. Sorry, folks. So I'm just going to throw another one out here. So 64. Okay, so we have a negative 73 is greater than or equal to the absolute value of negative 73. Okay, so first I suggest solving those two and then thinking about where would you put the inequality sign? Awesome. So if you say it's false, how would you rewrite that statement? Okay, so we drop, right? We drop the absolute value symbol, the negative stays out there. Anything coming out is a positive. So how would what inequality symbol would go in there? How would you write that? Yeah, so we're gonna say false, right? Because don't forget, we've got a negative out here, so that negative symbol comes down. And there's nothing over here. So, right, if we were to plot that on the number line, 73 is on this direction, positive, and negative 73 is in the negative side. Okay, let's try another one. So don't forget to solve the problem before you determine whether it's true or false. So 3 is greater than the absolute value of negative 4/3. So let's go ahead and solve this one, right? Anything that comes out stays positive. So 4/3. Okay, that's an improper. So if I don't understand what that is on a number line, I might turn it into a mixed number. So 3 into 4. And so that rewritten as a mixed number is 1 1/3. So I'll plot that 1, 2, 3. Here's 3. And then I'll chop this up 1, 2, 3. So 1/3, 1, 1 1/3. Okay, so 4/3 is less than, 3 is greater. So that is a true statement. Okay, so again, I find it helpful when I have improper fractions to change those into a mixed number, or you could change it into a decimal, right? And you could figure out where do you plot that on the number line. All right, so we're gonna take a break. Have you guys come back, let's say 10 minutes. I'm gonna put a 10-minute timer up here. Do what you need to do for 10. I'll give you guys 12 minutes. I usually take a break at 6:30. So 10-minute timer. I can't type. 10-minute timer. All right, there it goes. So I'm going to step away from the computer. Y'all do what you need to do. Oh, I said 12 minutes, didn't I? I'm sorry. Let's do a 12 minute. All right, there we go. 12 minutes. All right, we're back. Does anyone have any questions about absolute value, the number line system, before we move into a new section? Okay, no questions. Then the rest of the problems in sections 1.1 will ask you to graph absolute value. Okay, and then problems 83 through 92. Again, thinking about that variable x as all real numbers. Okay, so when you write those problems out, okay, remember to tell yourself as you are writing it out, x is all real numbers, and then write the inequality sign followed by whatever number. There might be a variable there. So think of it as x is all real numbers. All right, let's go into section 1.2. So addition and subtraction. It started 5 to 8. I had to change the time in Moodle because last semester I taught from 6 to 9. So I confused the time, but I did change everything in Moodle. And then let me show you. So if you miss any part of the lecture, here at the end of the chapter down here at the bottom, you'll find all of the lecture recordings. So I know, Grant, you keep getting kicked out because of connectivity issues. You'll be able to find the recording down here at the bottom. And so just watch the sections that you need to keep yourself caught up. Okay, you may not need to watch the whole thing over. You may just need to watch any sections that you may have missed. All right, so addition of integers or real numbers. Okay, so when we're adding, it's always helpful when we're adding integers to use a number line at first. Okay, and the purpose of the number line is to help you understand, right, what you are doing. Okay, so we've got a number line here. I'm going to label this positive. I'll label this side of our number line negative, right? Goes on forever, doesn't stop. Goes on the other direction, it doesn't stop. Okay, and so if I were to put a problem in here, so let's say we have working with number 2. Okay, number 2 on page 19. Okay, there are several ways that you could do this problem. Oh. Let's undo that, that's 3. Okay, so we would read this where we start off down here, right? 3, 4, 5, 6, 7, 8. So I start off on the number line at a positive 8. Okay, and my operation, this addition sign, okay, you might be tempted to go toward the positive direction. Okay, but you have to remember inside the parentheses, we have this negative, right? -3. So I'm not going to go in the positive direction. Okay, because this -3 is there, it's telling me I need to move negative, right? Negative is moving to the left. So I'm going to go back 3. 1, 2, 3. Okay, so -3. And then I'm going to count where am I at now on my number line? So I have 1, 2, 3, 4, 5. I ended up at positive 5. Okay, so for a while, as you are getting used to adding and subtracting integers, okay, you may use the number line. So let's try another one. Okay, so now I have -9 plus 5. Okay, so again, I'll do a number line here. Okay, so where on the number line am I going to begin? So in the chat, where am I starting off on my number line? Yeah, so I'm down here, right? I've got to go in the negative direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm down here at -9. Okay, and so I need to look at any of the operations that are next to the 5. So I don't see any negative there. There's nothing there. And I only see the positive. So I'm going to move in a positive direction. 5. I'm going to move over 5, 2, 3, 4, 5. And then I am going to count, where did I end up here on my number line? Well, I ended up, yeah, good, at the -4. So I end at -4. Okay, what about if I had something like this? Okay, so where do I start off? And which direction am I going to move? Yeah, so again, right, addition, when we think about addition problems, okay, your order matters. The order matters with integers. So we want to start off with whatever is at the front. Okay. Okay, because with integers, we're talking about both positive and negative. Integers are positive and negative. So the order is going to matter here, right? So we want to start off with what we have at the front. So we have a -7, 1, 2, 3, 4, 5, 6, 7. Okay, and which direction do we move? So again, right, we want to take a look at the operation here, but let's also look at this other operation next to it. Okay, so remembering, right, so we have a positive operation. Okay, and then that operation is multiplied by this operation. Okay, so again, it's this idea here. So we could rewrite that. Oh, I did that one twice. Sorry, I meant to put negative, negative. So if we take a look at this positive next to this negative, those two are this one here. So I could rewrite this problem and drop the negative sign or the positive sign in the parentheses and rewrite it as -7 minus 3. Or I could leave it -7 plus -3, understanding that in the parentheses, that is a -3. So I'm going in the negative direction, 3 more. 1, 2, 3. Okay, so then I count, what is this, right? That is a -10. Okay, so let's try another one like that. Just trying to find one like that. It's most of the odd ones. I'll just create one. Okay, so this one isn't in the book. I made this one up. Okay, so where do you start? Which direction do you move? Looks good. So yeah, we're going to count 12 negative. So we want to go down to -12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we'll start at -12. Okay, Carlita says move left. What do the rest of you think? Right, so taking a look at -12 plus -3, which direction do we move? Yeah, left. Good. Yeah, because this tells us we're going -3. We're going -3. So what is the answer? Yeah, good. We end up down there at -15, right? So we're continuing to go negative. Right, so it's the same idea of if I had $0, right, in my bank account, and I accidentally overdrafted by $12. If that overdraft fee was an additional, right, in addition, that would put me in the negative. So I would continue moving negative, right? As opposed to this problem here. Okay, so I went negative in my account and then I deposited 3 more. I end up going in a positive direction. Okay, so I'm at, my account becomes -$9. Okay, so people have a tendency to get confused between this one and this one. Pay attention to the operations here in the middle. Okay, so let's try another problem. So what is that one? Okay, and then do number 12. Those look good. Yeah, -9. Okay, so we're down here. And then if we went 3 the other direction, yeah, good. 9. Number 26. Looks good. Yeah, we want to recognize that we started at -20. Okay, and then recognizing those operations mean we continue to move in a negative direction. Good. All right, feel free to use a calculator for this one if you'd like. Okay, so I might start over here at 10.2. Okay, and negative, so I'm going negative 9.3 and then another negative 6.6. Okay, so I'm moving in a negative direction. Okay, so we'll line up our decimals. Okay, then we're at 0.9. Okay, and then we have a negative 6.6, and I might just stack them the other way and subtract. And then remembering, right, it's a negative, right? I'm going negative. So I have to put that negative back on there. I'm going to change this one. Okay, so I'm down here at a negative 31 minus 15, right? So I keep going in the negative direction. So make sure, right, when you write this out, that you do not forget your symbol on the front. Okay, so negative 31, I'm continuing in a negative direction. So not 46, right? Because positive 46, if you leave the negative sign off, it's way over here. And that's much different from when we keep going in the negative direction. That's much different than negative 46. Okay, and it can be very easy to forget your positive and negative symbols when you write your answer. So always remember, check your answer and ask yourself, does my answer make sense? Okay, so negative 46. Let's look at 52. Another one. Yeah, looks good. And then because we're continuing in a negative direction, we put that negative symbol back on there. Good. Okay, so when we talk about addition, okay, there are a couple of words we want to remember. We can see this word add. Add is the addition symbol, right? It means to add. And then the sum is the answer to an addition problem. Okay, so that also might look like this. So we call both of these in the addition problem an add-in. Okay, and then the answer we call the sum. So if you see sum in a word problem, it means to add. Okay, it means to find the answer to an addition problem. So let's take a look at 54. It's pretty straightforward. Add 9 and 11. Okay, so set that up in an operation and then include your answer. So add 9 and 11. How would you set that up, and what is the answer? Good, Brendan. So again, these are word problems where we are adding integers. So there's another one. Let's look good. Okay, so yeah, looks like everyone, right? 9 plus 11, that's how we set it up. Okay, so solve 56. So set up 56 as, yeah, as an operation. Yeah, so if you put plus negative 14, go ahead and throw the parentheses on there. Yeah, those look good. Yeah, I like that. So, right, 20 plus parenthesis, negative 14, close parenthesis. Okay, and then go ahead and set up 58. Yeah, so we're trying to find the answer to an addition problem. Looks good. All right, that takes care of section 1.2. A lot of this is just review. So let's move into section 1.3. Right, and 1.3 is subtraction. Subtracting integers. So we talked about the additive inverse, right? We've talked about this additive inverse, which states that some number, right, minus, well, that's not what I wanted to do. Some number minus itself is going to equal 0. Right, so we're going to start out on this number line. Okay, and we're going to have some number out here. And if we subtract it, the same number going back the opposite direction, we will end up at 0. Okay, the same thing applies if we're out here at some number out here in the negative. If we subtract the inverse, it will arrive back at 0. So let's think about the inverse. The inverse, when we talk about the inverse, you might think of it as opposite. Okay, so if we have 1 here, the inverse of 1 is -1. Okay, and that applies to any integers out here on the number line. Okay, so we'll do a few problems from 1.3. So number 2 wants to know, what is the inverse, the additive inverse for this integer? Okay, so in the chat, what is the additive inverse for 17? Yeah, so the inverse is -17, right? It's the opposite. What is the additive inverse of 10.1? Yeah, good. So we're on the opposite side of the number line at -10.1. Okay, and number 10, the additive inverse of -257. Good. Yeah, so the other side of the number line, 257. Okay, so some of the problems for subtraction, right, might look like this, 5 minus 7. So again, we're on the number line. Okay, we're starting off at 5. Okay, you move -7. What is the answer? Yeah, good, -2. Okay, now because this is subtraction, we no longer see the addition with the parentheses, but it's the same idea. Okay, so -18 minus 17. Right, so we're at -18. We move negative. Okay, so again, we're looking at the operation or operations in the middle. We see negative there. Okay, so we know we are continuing in this negative direction. Okay, the other thing you might do is add those together. Okay, but because we've got negatives on both of those, we put that negative sign right back on there. That's okay, Grant. If you need to watch the lecture recording later, I will post it tomorrow morning. Usually takes a few hours for the video recording to get to my email. So I always post the recording the next morning. Okay, yeah, so we'll end up down here somewhere at -35. this one? So make sure you think about this. Okay, so again, you're looking at the operation or operations right in the middle. So we have a negative and a negative there, these two. Okay, so I keep doing that. Sorry, guys. I meant to. Okay, so a negative and a negative, that operation changes to a positive. Negative times negative makes a positive. Okay, so we start off here at 5. Okay, and then you go 7 more. 1, 2, 3, 4, 5, 6, 7. So try this one then. 3 minus a minus 8. Good. Yeah, negative times the negative changes it to a positive. So you do end up with 11. Right, so thinking about your number line. Okay, so we're down here at negative 11. Okay, this direction, you should, you move right if the operation here is positive. Okay, you move left if that operation is negative. So it is negative, so we're going left, or we're moving in the negative direction. 5 more. Okay, and then you just count down. Negative 12, negative 13, 14, negative 15, negative 16. Negative 8.5 minus 7.1. That looks good, right? Because we're going negative. So negative 15.6. It's good. Do one more from this section, number 20, or from this small area. 4 minus 12. Good. Yeah. This one looks a little funky. 32, 19 minus positive 26. Yeah, so we might rewrite it 19 minus 26. So we would end up on the number line at -7. Number 34, -41 minus -8. So you might think of, how do I rewrite this? Right, so we might take a look at the operations right here. So we might rewrite it first. -41 minus a -8. Okay, and then from there, I might rewrite it one more time, right? We've got two negatives, make a positive. Okay, and it looks like most of you arrived at -33. Good. So sometimes we might have some word problems. Okay, so let's take a look at problem number 40. Okay, it gives you a hint there. So when we're working in subtraction, especially in word problems, your order matters. Okay, so you want to write the problem in the order that you see it. So for problem 40, it says find the difference between 30 and -12. Right, so in the chat, how do you set up that operation? And then you can find the answer. So first set it up in the chat for me. Find the difference between, so difference. So when we look at subtraction problems, difference means the answer to a subtraction problem. Looks good. Okay, so first I might put a line, right? I know it's to subtract and I'm gonna have to find the answer. Right, and looks like most of you set that up correctly. So 30, right? Subtract -12. And then, right, two negatives make a positive. Looks good. Okay, let's do another one. I'm just gonna write this one. Subtract -2 from 6. Right, so again, set that one up in the chat. So if it helps to put your 2 lines with a subtraction and then fill in the numbers. So lines equal. Looks good. Yeah, so you start at -2, move in the negative direction. -8. One more. Okay, you won't ever really see minuend and subtrahend. That's just something for you to take note of. So just like in addition, we have addend plus an addend equals the sum. For subtraction, we have minuend minus subtrahend equals the difference. Okay, and in subtraction, this is the term that you will see the most, is difference. All right, yeah, so we can put our lines in here. Right, so we fill it in 20, subtract 20 from -20. Okay, so this is where the term, it might be a little confusing. Okay, so let's pay attention to this from. Think about that. Right, so if we are subtracting 20, get my eraser here. If we are subtracting 20 from, this from indicates something a little bit different. Okay, so from means that we need to put this -20 out in the front over here. Okay, so if we put -20 here, right, because we have to subtract 20 from -20, the 20 then goes in the back here. Okay, so when you see from, it's telling you to put this number out front and subtract whatever number from it. Okay, so now we have -20 minus 20. What answer do you arrive at? Okay, so not 0, right? Because we don't have the, remember, if it was 0, right, we would need an additive inverse. Yeah, good. Yeah, so what we see here is that we are at -20 and then we continue -20 more. Okay, so we would end up at -40. Okay, so that one was a little tricky. Just pay attention to, if you see this word from here, it means that you have to kind of move your numbers around. Okay, so typically, yes, we would put them in order, but sometimes we might see from in a problem. Okay, so here's a little longer one. Give it a try. Problem 46. Sum of 11. Give that one a try. All right, I see some answers coming in. Okay, so let's set this problem up. First, we see the sum, right? So the sum means addition. Okay, so we'll solve that one first. Looks good, negative 12. Okay, and that was then. I forgot to put an N on there. Then the next thing we'll do is take our answer, okay, negative 12, and subtract 25. Yeah, so we end up at negative 37. Okay, so again, there is no negative on the front of 25. I think you accidentally, Brendan, probably went like this. If I looked at your problem correctly, you may have changed that. Yeah, so your 13 came from those two negatives in there, but that one was a positive 25, so it was just subtract positive 25. Okay. All right, and then in this chapter, you've got some word problems. I think I'm only going to do one of these and try to quickly get some multiplication in here. Multiplication and division. Because I want to focus next week on exponents, prime numbers, and lowest common multiples. All right, so let's take a look at 68. Let me make sure I typed this correctly. So according to NASA, the temperature on the Earth's moon during the day is 260 degrees Fahrenheit, and during the night it is negative 280 degrees Fahrenheit. What is the daily temperature change on the moon? What is the daily temperature change? Okay, so change is one of those words, right, where we think of subtraction. Okay, so how are you going to set this problem up? How might we set this problem up? Okay, so again, change, right? Change, we want to think of subtraction. Okay, and so our number line might go this direction, right? Because temperature, thermometers, right? So this can, drawing pictures out when you're working with word problems can help you kind of visualize what is going on. Okay, so we have 200, we'll pretend 260 degrees Fahrenheit is up here at the top. Okay, and so we have, right, at night, changes drastically. So you have negative 280 degrees Fahrenheit. Okay, so when you're thinking about the distance between these two, or the change, right? The change in the temperature. So it means to subtract. So we might, again, using our, right, our subtraction operation here, we could say, you know, we're going to have some number here, our negative sign, some number here, right? And then we'll arrive at our answer. How are you going to set this up? Okay, so in the chat, how might you set that up? And again, you want to ask yourself, when you arrive at your answer, does your answer make sense? It's a terrible color, isn't it? Okay, so again, from 260 to negative 280, what is that distance, or what is the change? What is the change in temperature? Yeah, that looks good, right? So we are starting off at 260 degrees Fahrenheit height here. Okay, and then we're subtracting, right? Change is subtraction, and we're subtracting negative 280. Okay, so when we rewrite that problem, our negative and our negative become a positive. Okay, and that's kind of what we're doing, right? So we have our distance from here to here, right? And then our distance from here to here. Okay, so we end up, right? So the change between those two temperatures is a 540. Okay, so we had a temperature change of 540 degrees. Okay, any questions so far? So you've got a bunch of other word problems. They're set up similar. And again, you want to think about, are they asking about change? How might I set up my problems? And drawing diagrams to help you think about those problems. Okay, any questions? 1.1, 1.2, 1.3. All right, let's jump into 1.4. Right, in 1.4, we are now moving into multiplying and dividing. Okay, so when we multiply, you saw this symbol, right? This times symbol. Emphasize, but that doesn't look good. Okay. We also can use a dot. Okay, and you might see parentheses. Okay, so all of these symbols indicate multiply. As you move forward, this times symbol, okay, multiply symbol, you're not going to see this one as much. Okay, because it looks a lot like our variable x, right? And we learned x, our variable. It is the most common variable that we use in algebra. Because it is the most common variable that we use, okay, if you had x times x squared times x cubed, it would get pretty confusing, right? So it would be really confusing to see something like this and think, is that x cubed, right? What am I doing here? Okay, and I could get the answer wrong. So we move away from this times symbol, and what we use then are the dot here, okay, and the parenthesis. So both of those indicate to multiply. And then in division, okay, in division, we have, right, this symbol. We can see this symbol. But in algebra, this fraction bar becomes one of the most common symbols that we see. Okay, because the fraction bar, let's say I use the variables a over b, means the same thing. Okay, b divided into a. Okay, but in division, most commonly, you are going to see a fraction bar. Okay, you'll see some of these others here and there, but it's going to be the fraction bar. So some of the rules, again, I talked earlier about when we see symbols. Okay, so I said positive times a positive. Okay, negative times a positive equals a negative. And then a negative times a negative equals a positive. You see, these are our rules of multiplying integers. Okay. So rules of multiplying integers. And if you look on page 33 of your textbook, okay, what they're using there is they're using variables. Okay, so we have a times b, right? Those are positive. It'll give you a positive ab. Way ab. Okay, a negative a times a positive b. You'll end up with a negative ab. And then a negative times a negative will give you a positive. Okay, so these are the rules of multiplying integers. Okay, I like to use it without the variables. It just makes a little bit more sense, but I would need you to understand that these variables, they help us to learn the rules. Okay, and then of course, any number times 0 always equals 0. And then any number times 1 equals itself. Okay, so those are some rules that we have when we multiply integers. Okay, rules for division. Okay, you cannot have any number divided by 0. So again, 0 cannot be in the denominator. Okay, and when it is in the denominator, we say it's undefined. Okay, so when you are solving your problems, if this becomes an answer, then you will write undefined as your answer. Okay, so that is an important rule. Okay, but if you have a 0 in the numerator, okay, it is just 0. Okay, so that is an important rule. Okay, other things to remember. Okay, so when we divide by positive numbers, again, just like multiplying, right? When we divide by positive numbers, we end up with a positive number. Okay, but if we divide by negative numbers, both top and bottom, you will end up with a positive answer. Okay. And then I'll put it up here, I'm running out of room. When we divide by a negative, so if that negative is in the numerator or the denominator, right, we're gonna still end up with a negative answer. Okay, so rules of division and rules of multiplication. All right, let's do a few. I have 7 minutes before I run out of time. So then I'm just gonna toss some problems in here and you guys just answer in the chat. So we'll do a few multiplication. And these are pretty straightforward. Again, it's remembering what the rules are so you end up with the correct answer. And oftentimes I find that students rush through these problems and they forget, right? They forget what the negative or positive number is. And so then we end up with an incorrect answer. Okay, so rules and making sure that you attach that negative symbol if it was supposed to be there. All right, so in the chat, go ahead and put the 4 answers to those. Yeah, good. So we've got negative 30, right? Negative times a positive, positive times a positive, negative times a negative makes a positive, and then the same thing, positive. Good. Okay, and then problems 25 through 46, again, like I mentioned, we see division as a fraction bar. Okay, and you're gonna see this a lot. So it looks like a fraction, right? Because division is fractions. They are the exact same thing. Okay, so you just need to remember the denominator moves to the outside, the numerator goes under the symbol. Okay, so go ahead and give that one a try. Negative 10 divided into negative 20. Yeah, good. It's the same thing as saying negative 10 right, times some number is equal to -20. Okay, so because the answer is -20, or we might say, again, the rule, negative divided into a negative, we would end up with a positive answer. Okay, so 2. Let's try another one of those. Okay, so problem 28, -51/3. Good. All right, we'll do one more of those, and then when we come back next week, I'll do a couple of the word problems, probably like 2, and then we'll jump into section 1.5. So problem 42, the last one for tonight, -5.6/7. Looks good. Yep, -0.8. Awesome. All right, you guys, so that is all I have for tonight as far as lecture. Again, let's go quickly back into Moodle. So you do have the links here, but because again, you're not going to have the Rocketbook begin until probably later this week. For those who missed it, I just dropped those into the mail. So US Postal Service, check whatever you had listed when you registered with MPC. So that's where I sent it. I just pulled a roster and mailed all of those out today. So once you get those, I do have the directions here, right? The guides for how to get it going. If you're struggling, by all means, next week, just either pop into my office hours or send me a message, and I can help you get started with that. Okay, if you were going in and out of the lecture, down here at the end, I will put the recording from this lecture. So just again, tomorrow morning, I will put it in there and you can just pop in and take a look at it. Okay. As you're working on your homework assignments, make sure, again, if you got any questions on anything, highlight it and bring it. So how it'll work from here on out as we move forward is I will leave time right at the beginning. We'll do a quick review. You can ask your questions and then we'll jump into the next sections. Okay, so for next week, I will focus a lot on section 1.5. Lowest common denominator tends to be something that folks struggle with. So that's one that I will focus on. And then hopefully with the understanding with 1.5, we can kind of roll through 1.7 through 1.9. Okay. All right, you guys have a great weekend and week, right? We're only on Monday and I'm thinking about the weekend. So y'all enjoy yourselves this week. Reach out to me in office hours again if you have questions. All right, you guys have a good night. We'll talk to you later.